Welcome to the ultimate cosmic journey, where we explore the universe's most dangerous secrets, right here on Dark Sky Dive. Jupiter stands as the king of planets, a swirling gas giant that has captivated human imagination for thousands of years. It is a world of immense proportions, capable of fitting over 1,300 Earths inside its massive volume. Humanity has always dreamed of visiting this giant, imagining a future where we might one day walk upon its surface. However, the reality of such a mission is not a dream, but a nightmare of physics that forbids our presence. To understand why we cannot land, we must dissect the two non-negotiable enemies of human technology: radiation and pressure. Before we even touch the atmosphere, we encounter the first guardian of hell, an invisible barrier of lethal charged particles. Jupiter possesses a magnetic field 20,000 times stronger than Earth, creating the largest structure in our entire solar system. This magnetic field acts as a particle accelerator, trapping electrons and ions, turning the space around Jupiter into a microwave. Any astronaut daring to approach would be subjected to radiation doses thousands of times higher than what is considered safe. Without impossible protection, this radiation would penetrate the hull, the suit, and finally the skin of the traveler within minutes. The immediate result would be acute radiation syndrome, where your very DNA is shredded, halting cell regeneration throughout your body. Internal organs would begin to fail simultaneously, leading to a painful and inevitable death within just hours or a few days. Even our most advanced robotic explorer, Juno, requires a heavy titanium vault just to protect its sensitive computer brain. Despite this heavy armor, the probe still suffers damage over time, its electronics slowly degrading with every orbit it completes. To protect a human crew, we would need a spacecraft with walls of lead or water several meters thick. Such a vessel would be too heavy to launch with current rocket technology, grounding our dreams before they even begin. Even if we solve the radiation problem, the planet itself offers no welcome mat, only a deceptive and beautiful trap. Jupiter has no solid surface to land on. It is a transition from gas to liquid that defies human intuition. There is no ground to plant a flag, only an endless abyss that gets hotter and denser the deeper you go. As we descend through the upper cloud decks, the view is breathtakingly beautiful, but the environment is becoming increasingly hostile. Winds on Jupiter scream at hundreds of miles per hour, creating shear forces that would tear a standard structure apart. We approach the Great Red Spot, a storm that has raged for centuries, large enough to swallow our entire home planet. Here, lightning bolts are thousands of times more powerful than on Earth, striking with enough energy to vaporize a ship. Navigating this turbulence is impossible. There is no stable air to fly in, only chaotic currents of violent gas. As we sink deeper, the sunlight fades away completely, leaving us in eternal darkness, illuminated only by violent lightning flashes. Now we face the second enemy, pressure. The weight of the atmosphere above begins to crush down with unimaginable force. Imagine the pressure at the bottom of Earth's deepest ocean, then multiply that force by a factor of thousands. At this depth, the pressure is millions of times that of Earth's sea level, enough to crush any known material. The gas around us is no longer just gas, it is being compressed into a supercritical fluid, a strange state of matter. Temperature rises in lockstep with pressure. It is no longer freezing cold, it is now becoming oven hot. We saw this happen to the Galileo probe, which survived only minutes before being crushed and melted by the unforgiving environment. Deeper still, we reach a realm where hydrogen is squeezed so tightly that it turns into a liquid metal. This metallic hydrogen ocean is the source of Jupiter's magnetic field, a churning, conducting fluid that is completely alien to us. Here, no ship can exist. The vessel would be crushed into a small ball of scrap and then vaporized instantly. At the very center lies the core, a mystery that scientists are still trying to understand, potentially hotter than the sun's surface. Temperatures here can reach tens of thousands of degrees, a hellscape where matter exists in states we cannot replicate. So, the dream of landing on Jupiter is physically impossible. It is a forbidden kingdom that destroys all who enter. However, this does not mean we must abandon the Jovian system entirely. There is hope nearby, just not on the planet. Space agencies have shifted their focus to the icy moons, particularly Europa, which offers a much more promising destination for humanity. Beneath its frozen shell lies a global ocean of liquid water, containing more water than all of Earth's oceans combined. Here, shielded by the ice from Jupiter's radiation, life might actually exist, and humans could potentially build a base. Ganymede is another target, the only moon with its own magnetic field, offering some natural protection against the deadly radiation. A colony here would provide a front-row seat to the grandeur of Jupiter without the immediate death sentence of landing. Callisto, orbiting further out, is arguably the safest bet for a human outpost, located outside the worst of the radiation belts. For now, we send our robot avatars to brave the dangers, gathering data and paving the way for future generations. Jupiter remains a beautiful monster, a planet that demands our respect and admiration, but strictly from a very safe distance. As we look up at the night sky, we see it as a bright wandering star, a reminder of nature's extreme power. Perhaps one day, technology will advance enough to allow us a deeper look, but for now, the giant keeps its secrets. The storms will continue to rage, the radiation will continue to burn, and the pressure will continue to crush everything. It is a failed star with its own solar system of moons, a kingdom where humanity is merely a fleeting observer. It acts as a shield for Earth, absorbing asteroids and comets that might otherwise threaten our own fragile existence here. In studying the hellish conditions of Jupiter, we learn to appreciate the rare and delicate paradise that is our Earth. Our journey today ends at the edge of the abyss, having witnessed the power that forbids us from going further. Thank you for exploring the cosmos with us. Remember to subscribe to Dark Sky Dive for more deep space mysteries. Stay curious, stay safe, and keep your eyes on the stars. We will see you in the next video. Let's take a moment to appreciate the sheer scale of these storms, larger than continents and lasting for centuries. A single white oval storm on Jupiter could cover the entire landmass of Asia and Europe combined with ease. The iconic stripes are actually jet streams moving in opposite directions at hundreds of miles per hour, tearing clouds apart. High up, the temperature is cold enough for ammonia to freeze, creating clouds made of ice crystals rather than water. Deeper down, water clouds exist, and this is where the most violent thunderstorms in the solar system are born. Some theories suggest that deep inside, the pressure turns carbon into diamonds, creating a literal rain of precious gems. But don't plan a mining trip. These diamonds eventually melt into a liquid sea under the intense heat below. Gravity on Jupiter is 2.4 times that of Earth. A 100-pound person would weigh 240 there. This crushing gravity would make simple movements exhausting and put immense strain on your heart and circulatory system instantly. To simply hover in the atmosphere, a ship would need constant, massive thrust, burning through fuel reserves in minutes. Once the fuel runs out, the ship would succumb to gravity, beginning the one-way trip into the crushing depths. Jupiter is also a loud radio source. Its noise can be detected from Earth, sounding like static from hell. These radio emissions are caused by the interaction of the magnetic field with charged particles from the moon Io. Io is the most volcanic place in the solar system, constantly spewing material that feeds Jupiter's deadly radiation belts. This material forms a plasma torus, a donut-shaped ring of charged particles that creates a hazardous zone for ships. Navigating around this torus is essential, adding another layer of complexity to any potential mission to the Jovian system. The auroras on Jupiter are not just light. They emit high-energy X-rays that would cook any nearby observer. Unlike Earth's auroras, which are driven by the sun, Jupiter's are powered by its own internal rotation and moons. In 1994, we watched Comet Shoemaker-Levy 9 slam into Jupiter, creating explosions larger than the entire Earth. Those scars remain visible for months, a testament to the violence that occurs in the atmosphere of this giant. If such an impact happened on Earth, it would have been an extinction-level event for all life forms here. Jupiter acts as a cosmic vacuum cleaner, its gravity influencing the path of every object in the solar system. It was the first planet to form, swallowing up most of the gas and dust left over from the Sun's birth. Its massive presence prevented a planet from forming between Mars and itself, leaving us with the asteroid belt instead. Back to the pressure issue. Even carbon fiber, our strongest material, would shatter like glass at moderate depths. Even theoretical materials like graphene might not withstand the forces found deep within the metallic hydrogen ocean layer. Any probe sent deep down is on a suicide mission, transmitting data until the very last second of survival. The final transmission from such a probe gives us precious clues about the composition and history of our solar system. From the inner moon Amalthea, Jupiter would span an incredible 46 degrees of the sky, a terrifying sight. But standing there would be fatal instantly, as Amalthea orbits deep within the most intense radiation belts of all. Jupiter does have rings, though they are faint and made of dust, unlike the spectacular ice rings of Saturn. These rings are created by dust kicked up from meteor impacts on the small inner moons of the system. To reach Jupiter quickly and minimize radiation exposure, we need faster propulsion, like nuclear thermal rockets of the future. Speed is safety. The less time spent in the radiation belts, the better the chances of survival for the crew. Long-term missions would require artificial gravity to keep the crew healthy during the long transit and orbital stay. Living in deep space requires simulating Earth-like conditions to prevent muscle atrophy and bone density loss over years. We could mine the ice on the outer moons to produce water, oxygen, and hydrogen fuel for the return trip. Jupiter could eventually become a gateway, a refueling stop for missions heading further out to Saturn, Uranus, and Neptune. But that is a story for another time. For now, Jupiter remains the primary boss fight of our solar system. To summarize, radiation destroys your body, pressure crushes your ship, and heat melts whatever is left of the wreckage. It is a humbling reminder that the universe was not built for us, and we exist only by its mercy. Yet, our curiosity is stronger than our fear. We will continue to study, to probe, and to wonder why. New telescopes like James Webb are revealing details about the atmosphere and rings that we have never seen before. Infrared imaging allows us to peer through the top cloud layers and see the thermal heat escaping from the deep interior. Scientists are desperate to know how much water is on Jupiter, a key to understanding how the solar system formed. The European Space Agency's JUICE mission is on its way to explore the icy moons and the giant planet itself. NASA's Europa clipper will also arrive soon, specifically hunting for conditions suitable for life in the moon's subsurface ocean. We are entering a golden age of Jovian exploration, where our knowledge of this giant will grow exponentially in coming years. If we find life on Europa, it would change our understanding of biology and our place in the universe forever. Ironically, the deadly radiation of Jupiter might provide the energy needed to sustain life hidden beneath the ice of its moons. The gravity of Jupiter squeezes and stretches the moons, creating heat that keeps their internal oceans from freezing solid. Without the massive presence of Jupiter, these moons would be dead, frozen worlds of rock and ice like Pluto. So while Jupiter is a killer, it is also a life-giver, a complex engine of destruction and creation combined. The patterns in the clouds are fluid dynamics art on a planetary scale, constantly changing and evolving every single day. We have observed the great red spot shrinking and changing color, reminding us that nothing on this planet is static. Some scientists predict the storm could disappear entirely in our lifetime, ending a centuries-old phenomenon observed by astronomers. But as old storms die, new ones are born, rising from the heat of the deep interior to roil the surface. This cycle of atmospheric violence has continued for billions of years and will continue long after humanity is gone. Jupiter has inspired countless science fiction stories, from Arthur C. Clarke's Monolith to modern space operas of today. It represents the unknown, the powerful, and the sublime, triggering both fear and awe in the human psyche. Even through a small backyard telescope, seeing the moons line up around the planet is a magical experience for anyone. We encourage you to go out and look up. Seeing the king of planets with your own eyes is unforgettable. Jupiter is just one of many gas giants. Our galaxy is full of them, some even hotter and larger than ours. We have found hot Jupiters orbiting other stars, gas giants that are being roasted at close range by their suns. Studying our own Jupiter helps us understand these distant worlds, bridging the gap between our home and the stars. Fundamental research into planetary science is not just about space. It helps us understand physics and chemistry everywhere. Every discovery we make at Jupiter adds a piece to the puzzle of how our universe works and evolved. So, we leave Jupiter to its lonely vigil, a giant guardian spinning in the dark, beautiful but deadly to the touch. We will likely never walk there, but we can admire it, study it, and respect the boundaries of nature. We have journeyed through radiation belts, dived into storms, and been crushed by pressure in this 18-minute adventure. We hope this deep dive has given you a new perspective on why some places are best left untouched by man. If you enjoyed this, check out our other videos on Saturn's rings or the mysteries of the black holes nearby. Your support keeps us flying. Hit that subscribe button and ring the bell so you never miss a launch. Let us know in the comments, would you visit Europa if you had the chance? We love hearing your thoughts. The universe is vast and full of wonders waiting to be explored. We are just getting started on this journey. From the rocky inner worlds to the gas giants and beyond, Dark Sky Dive is your portal to the cosmos. Thank you for spending your valuable time with us today. We appreciate every single viewer who joins our community. Until next time, keep looking up, keep wondering, and never stop exploring the dark skies above you. This has been a Dark Sky Dive production. Thank you for watching, and we will see you in the next one.